Okay, we'll have like 30 seconds to take a picture of this slide. You should take a picture of this slide in the next 30 seconds, because then we're going to actually show you the website behind that QR code. All right, so my name is Christine Task. I work with Gary Howarth at NIST. I'm guessing folks may have recognized my name from emails you receive a few times a year on our work. If you have gotten one of those emails and not clicked through to see the website, today you're going to get to see the website. So, on to that. We work, and this is relevant to an arm of the OpenDP library that you've seen, the smart noise synthesizers. So those are working on the problem of data de-identification. This is, we have tabular data, sensitive data on individuals. We want to be able to release that data publicly or share it in such a way that nobody can re-identify any individual in the data. There are a variety of techniques for doing that. They have a variety of behaviors, both in terms of privacy and utility. To enable their use safely and robustly in production, we want to understand them better. We want to strengthen the science behind them. So, welcome to the collaborative research cycle. We begin with a benchmark data set called the diverse community excerpts. Diverse because we are focusing specifically on geographies, regions, communities with diverse populations. Those are more likely to produce interesting behaviors from these de-identification algorithms. If you have a de-identification synthetic data technique, and you run it on our data, that will enable you to use our evaluator to generate a report that shows those interesting behaviors with as many metrics as we can collect. So this is NIST. They are good at collecting metrics. So, see some examples here, and we have ones already from the smart noise in OpenDP. So, this is what the report looks like. It's got a variety of metadata. It will tell you your overall utility score based on K-marginal, which was used for the NIST challenges. It has univariate. You're going to have to forgive me for scrolling. And I know there's a small resolution here, so it's going to be ugly. It does pairwise correlation. It will show you regression on education versus income as it differs by subgroup in the population. So you can see how diversity and the strength of correlations impacts utility, and you can see that utility goes down as the distributions get more interesting. We have propensity, popular metric. Another utility metric, we have PCA, which lets you directly see the data as 2D scatter plots and see the differences in the distributions. You zoom up so you can see it better, and you can see where there are mismatches. In this case, this particular algorithm is making divorced 6-year-olds. That is that streak right there that shouldn't be there. And we will tell you about that. So these are the inconsistencies. And here we see that 3.8% of the data shows an inconsistency with respect to age. This is our 5-year-old military veteran. All right. We have privacy metrics. There are more things there. Moving on. That's not the end of what happens. Good. All right. So, okay, we've gotten so far. Here was the data. You ran on the data. You got a report. You sent us your data. That is the next step. Up here and participate, we give instructions for you to send us on your technique or any other technique that you want to use, the de-identified version of our benchmark data. When you do that, if we don't already have it, we add your technique to our list of very many techniques. If you want to know what techniques there are out there for doing de-identified data, you can come check our website. We have library links, we have documentation. These include public libraries, proprietary libraries. This includes traditional disclosure control, variety of things. Also, we have 450 samples right now from people who have already contributed, although there's plenty more to go. This is a summary table that shows the privacy and utility, kind of a snapshot, not all the detail from the report, things about the feature space size they ran on, the number of samples we have from each. So you can see that sometimes varies. We have 45 samples from the AIM synthesizer, it's a great one, and the Smart Noise library. And we have 3 from Anano, so it's interesting to compare them. Have SARS in here, we'll be talking later. Okay, we have 450 data samples. They're on our benchmark data, they produce interesting behavior. Our goal is to understand and do the science that remains to be done to understand and be able to predict the behavior of these algorithms on that data. So we make all of that available to you. We have the archive that we release periodic updates, all of those samples, all of those metrics. You can look at it in a programmatic navigational way, or you could actually just look at all the PDFs of meta reports, one meta report for every library that lets you compare things. We don't stop there, we provide you with tools. So these are notebooks. If you don't know pandas, we will teach you pandas. We provide everything you need, a student needs, a newcomer, to go look across all those metrics and those 450 data samples and do really cool things. Really interesting comparisons. Here we see SARS and looking at performance on various things here with neural network techniques. We have sample algorithms that show, this is my favorite one. This is a privacy utility trade-off graph, not based on epsilon, but based on empirical checks for both, covering differentially private, not differentially private things. You'll see some techniques do great on privacy and utility. Some do bad on privacy and utility. So when we start looking at these things in practice, they get complex. It gets even better. We have a point-and-click interactive tool that lets you go play with your data and with the principal component analysis. So you can look across different components. You can highlight people, see who they are. Those 6-year-olds who are military veterans, you can track them down. And you can do this for your algorithm. You can do this for anything in our archive. All of this free, all of this fun. We would love for you to do something back for us. This is our call for papers under participate. So we are collecting 4-page research reports on November 7th. And it's just a research report. On anything you want to, find anything you want to, make it please reasonably coherent, but all we want is as many observations on this resource page as we can get. So take an existing paper, run your own new evaluation on it, an existing paper, run an evaluation on our benchmark data, and we will add your observations to all of the observations that we have, and we are making progress. I had an intern who was able to use this archive this summer to find a little quirk in the data. It was students in dorms between 18 and age 20, a little part of the distribution that caused problems, or all of the neural network techniques, and only the neural network techniques. Don't know why, would love to know why. The more things you send us, the more open problems we'll be able to share and the more progress we'll be able to make. Thank you very much.
All right, so our next pitch. Stay here if you wish.
Hi everyone, my name is Priyanka Nanayakara, and I'm a PhD candidate in computer science and communication at Northwestern University in Chicago. And today I'm presenting to you on behalf of myself and my collaborators, Marianne Smart, Dr. Rachel Cummings, Dr. Gabriel Kowchuk, and Dr. Alyssa Red-Miles. And specifically, I'd like to make a pitch to those of you who are working in organizations across industry, government, and academia who are actually deploying DP. And in particular, I want to provide an opportunity for you to work with us to increase transparency around DP guarantees with your end users. So over the past couple of years, my collaborators and I have been working on developing portable explanation methods for DP guarantees, and now we're looking to bring them into practice. So that brings me to part one of my pitch. we are suggesting that we can work closely with your team to port our explanations into your specific deployment context. We think that this would increase transparency with your end users. And we also want to benefit the broader academic community by writing up lessons that we learned from this process about challenges and publishing that in some sort of academic magazine article or blog post. Taking it one step further is part 2 of the pitch, where we envision not only porting our explanations into your context, but also then running some sort of field experiment or A/B test with these explanations. We show them to your end users, and we find out whether showing some sort of DP explanation or no explanation at all has any impact on people's behavior. So for example, whether they download an application or share data. And again, we envision sharing our findings more broadly with the academic community through publications. So now I want to direct your attention to the bottom half of the screen. These are some examples of the explanation methods that we've been developing. So if you look at number 1, this is an approach that we took to explain implications of information flows that are restricted or permitted given a particular DP deployment model like local or central. So in this work, we tried different approaches like metaphors, diagrams, and privacy labels, which you see on screen. And we found that privacy labels were most effective in helping people understand which information flows are restricted. And when you add a piece of text that describes the process of DP, like adding noise, this additionally improves trust. We showed this explanation to in a survey of about 700 people. But again, we want to try to bring this more into the real world. Number 2 shows you the explanation method that we developed for conveying implications of epsilon, the privacy loss budget. And so this is our odds-based visual explanation method where we show 2 probabilities, the probability of a negative outcome occurring if the end user does not share data, and then the probability of the negative outcome occurring if they do share data. And again, we drew on best practices from risk communication and usability to come up with this explanation. And we showed this to over 900 people, all of our approaches, and we found that this one was the most effective in increasing objective risk comprehension and helping people feel like they have the information they need to make a data sharing decision. And one last finding from this study is on the right-hand side. So we found that people are in fact sensitive to changes in epsilon in this controlled setting. So there was increased willingness to share data with increased privacy strength. So yeah, so we would love to work with you to actually bring these explanations into practice. Our team is really multidisciplinary. Across us all, we have expertise in differential privacy and cryptography and human-computer interaction, usable privacy and security, and visualization. And members of our team in the past have worked with partner organizations like what we're proposing specifically with Facebook and the state of Louisiana's COVID exposure notification app. This has led to significant improvement in partner organizations' goals, as well as academic publications. So we really want to make this happen with you all in the DP transparency space as well. Thank you.
All right, so our next pitch is actually online. Bear with me.
Can you hear me?
I can hear you. I just want to see you. How did we do this last time? Oh.
And Victoria was in our first cohort of OpenDP fellows.
Yes.
Welcome back.
Thanks.
Hold on, let me get it out of the way of the QR code. Okay, take it away, Victoria.
Okay. Hello, everyone. Thanks for the opportunity of this speech. I'm Victoria de Saint-Agathe, and I'm a research engineer at Sarus. Sarus is a startup developing an application for the analysis of sensitive data through SQL, classical machine learning, and deep learning. In my talk, I will focus on the SQL part of the analysis, which is done with the open source Curlew package. Curlew enables anyone to produce the differentially private version of an SQL query. And the result of that differentially private query is differentially private, of course. And the user can take this query and send it to a database and be confident of the privacy of the result. So the core of this task lies in taking an SQL query, transforming it into an abstract syntactic tree, and then reorganize that tree in order to ensure that once translated back into an SQL query, the result has differential privacy guarantees. So initially for this task, we had an internal package based on smart noise. However, the diversity and complexity of the SQL queries were a significant challenge, especially with intricate subqueries and joins. And in such cases, tracking the user ID and the sensitivity of the query became particularly tricky. So this is why we have implemented Curlew, which is an open source package written in Rust with Python bindings. And Curlew introduces an intermediate representation called a relation, simplifying the abstract syntactic tree. A relation can take on various variants, and each of those variants comes with a specific behavior regarding how sensitivity and the user ID are handled. Leveraging relations is advantageous because we can propagate the input colon ranges for computing the sensitivity and the user ID across all the SQL operations. And these capabilities allows us to compile nearly any SQL query into differential privacy. So on the schema here, you may see an overview of the main step of our algorithm. So we start with an SQL query, which is a string. And in step 1, we parse this query and create a relation tree. And then in step 2, we compile this tree into differential privacy. So this is during this step 2 that we do all the operations specific to differential privacy. First, we propagate the user ID and the sensitivity through all the relations. Then we introduce noise scaled by the appropriate sensitivity to each of the aggregation functions. And then we identify the grouping keys that can be safely released. And once all these things are done, we can transform back this relation tree into an SQL query and send it to a database. What is important here is that no additional post-processing is required, and the results obtained are differentially private with the privacy parameter that has been set by the analyst. So basically, using Curlew allows anyone to generate the differentially private equivalent of an SQL query. And then the user can send the DB query to his database and confidently ensure the privacy guarantees of the results. So looking ahead, we would like to connect Curlew with OpenDP, and this integration will enable an SQL query to seamlessly interface with the wide array of possibilities offered by OpenDP. But given time constraint, I will refrain from delving more into the technicalities here, but I invite you to scan this QR code and explore our notebook where all these things are detailed. Moreover, we will be very happy to have new user and contributor to that project. Thank you for your attention.
Thank you, Victoria. Did everyone get a chance? QR code? All right. Claudine, let me find you. But 1 second, I'll get you pinned. I'm getting the hang of this. Hold on. Let's see, where can I put you that you're not in the, there you go. Take it away, Claudine.
Thanks, Sharon. Hi, everyone. I'm Claudine Lim, and I'm the program manager at data.org. And so what I'll be presenting on today is one of the projects that we have happening in our Epiverse program. But first, before I jump into my very rudimentary slides, I'll give you a little bit of context on the Epiverse program. So in September 2021, my organization, data.org, launched Epiverse as part of a global initiative to empower epidemic preparedness and response efforts, with the aim of being more connected and informed among public health experts and decision makers. And since then, we have convened different stakeholders in public health, data science, data privacy, and open source software to help inform our approach. And part of the problem that we are trying to solve is the fragmentations within health systems. COVID-19 was a very disruptive force that revealed the need for really two critical factors. One, accurate and timely data, and two, the tools that were needed to actually analyze and translate the data into actionable insights. So we're working with teams from Colombia and the UK to build these tools, but in the Epiverse work, we've also noticed another issue. And that new issue that we're actually trying to solve in the ecosystem is how not to only use open data sets and public data, but how we can leverage non-traditional commercial data for these same public health efforts. These forms of data can be really valuable to unlock greater insights for policy decisions and is useful when public or open health data is scarce. However, that challenge that I was talking about is that using privately held data can pose privacy and security risks. So while privacy enhancing technologies or PETs has progressed significantly over recent years, we recognize that more needs to be done to enable more data sharing agreements across the globe and unlock privately held data's potential. So in sum, the challenge is to balance the need for accurate data and protecting the privacy of the users that the data belongs to. So along with some partners, we are hosting or holding a privacy enhancing technologies challenge that will launch Q1 next year. So we are working with a private company, Harvard OpenDP, and the University of Habanera in Colombia, and researchers from those institutions to design an open challenge that will leverage merchant data in Latin America to showcase its relevance to epidemic preparedness and response. And hopefully that this will demonstrate an enhanced application of privacy preservation techniques. So what the challenge really is about is this private company will be providing access to a representative synthetic data set of aggregated transaction data. Harvard OpenDP is defining a baseline solution for challenge participants to build on. And the University of Habanera will co-design the baseline solution with Harvard OpenDP. They'll be designing the baseline solution and lead on developing and formalizing use cases. And we're also working with some big cloud providers for a sandbox solution, and they'll be developing that to address the security and data access to the data from the private company. So my pitch to everyone is to participate in the challenge once it's launched. So we'll be inviting teams from around the world to answer the question of how to use the data provided to understand the population behavior at different points in the pandemic, with the intention of informing policy in future pandemics or other sorts of variants. And we are hoping that the outputs of this will be replicable in other sectors. So as I just mentioned, this open call is projected to launch Q1 of 2024. We are still working on some of on some of the standards and requirements. So this is really a first look at the challenge for this audience. And the applications will be scored based on two parameters. One, on improvements in accuracy of using that data, and two, the proposed approach can support use cases that test decision-making on COVID data. And so some incentives are that there will be a 250,000 financial prize awarded to the winners, and those selected approaches will be published and shared through us via a case study. We'll publish the methodology and a white paper detailing the set of recommendations and insights, as well as promoting through different leadership pieces within our networks. So if you'd like to learn more or just keep abreast of this challenge, we have nothing like super public as of yet, but you can keep in touch with me on my email, claudine@data.org, or just connect with us either via our website or through our LinkedIn. Thanks, that's it from me.
Actually, just a quick plug, part of that baseline solution was in coordination with a number of our OpenDP community members, most especially Christine and Gary from NIST, as well as Jack from Oblivious, will be here in a couple hours. So big help, and love the connection and collaboration.
And the work of our intern, Yanis.
And Giannis right there. All right, I think I lost count. Are we on 5? I think we're on 5. All right, Marco. All right.
All right, since we are a bit behind on time, I will be quicker. So because I think lunch is ready. So just to follow up to what both Salim and Andy said, we are trying to make the formal vetting process of the component of the library more formal. And so we are building a review board, a proof review board, of people that will help us to make this process more formal. If you have experience with academic review, this will be very similar, but we also want to review code. So we will need to put hands not only over the proof, but also on the code. So we are looking for people that have expertise in reading proof and reading code. There are not many, maybe, but we want to have more and more. So the ideal target would be either a practitioner that are used to read also proof, or students and postdoc who are used to both writing proof, read proof, and writing code. So these are the expertise we are looking for. We are looking for so on top, we are looking for a 6 to 8 member of the board. The board will also be run a bit like an editorial board of a journal, so we will have some people in charge of the work of the board member. We will start with our team, so Salil and my colleague will help organize this board, and we will make sure that the code is vetted in the right way. Hopefully, we will also use some tool to make the vetting of the code for bug a bit more, a bit easier, but a lot of it will be manual checking of the code. So if you are interested, or you have a student that is interested, or you think that your student should do it, this, you think your employee should do this, you can write an email to this email address, proofreview@opendp.org. I don't know if it's already active. It's good. Okay, it's good to go. So just write there, and we will receive the nomination. If we will not have enough nomination, we will try to pool. Okay. Yes.
Just real quick, when we did this for the NIST challenges, it did require them to write a code guide that told you for each point of the proof where to find it in the code.
Yeah.
So it is possible to do this without your brain falling out your ears. We did a whole batch of these. Great for students, just want to say.
I think also some previous intern have done this work, so we have already a good setup on how to do this, and this is why we are trying to form now the review board. Thanks. All right, that's it.
All right, we are officially on lunch. All right, so until 1:30, we will be back into this room. Lunch is served outside. Please remember, you cannot bring food into this auditorium, so eat out in the open area. And we'll see you in about an hour. Thank you.